Here is question number 5, and later on in your math life you will see question number 5 in this is the unit circle. It's known as, it's in trigonometry. You'll see it in the future math course. So you're given this figure and your attention is drawn to this triangle PAO. You're told that it's a right triangle and that its hypotenuse is 1. Alright, and then they're asking you how large is each angle of a triangle PAO. And the reason they ask you that is so that you can see what kind of triangle this is. But you might not have thought to do that on your own, so it kind of leads you to do that. And here's what you discover. Obviously PAO is a right angle, so it's 90 degrees. And then it says AOP equals 30 degrees. Now how did they ever come up with that? Because of this. You see, this is 210 degrees. They're saying from there to there. Well, part of that is a semicircle. That part. That's 180 degrees. So then 210, which is the whole distance, minus 180, which is the distance up to this point, is 30 degrees. So that means that angle AOP is 30 degrees. Well, then we can easily figure out what angle APO is. If I got a 90 and a 30 degree angle, then this one's got to be 60. Now I think you can see why they wanted you to figure that out, because now you can tell what the exact lengths are of the other sides of the right triangle, because if you know your 30-60 right triangle rules, you know that the hypotenuse is 1. So the short leg has got to be half of that, because the hypotenuse is twice as long as the short leg in a 30-60 right triangle. Right? So that means that AP, or PA as they've got it marked, is 1/2. And then you know that the long leg of the right triangle in a 30-60 right triangle, which is AO, is the length of the short leg, which is 1/2, times the square root of 3. So that's how you come up with these figures. Oh, that's the 30 degree angle. Okay, OP1 is given to us. AP is 1/2. That's the short leg. And what do they mean? What do they have square root of 3 over 2 for? Because if I do this, 1/2 times the square root of 3, what do I get? I get 1 times the square root of 3 is the square root of 3. It's the square root of 3 over 2. Those are exact lengths. So now they ask me to find the coordinates of point P, way out here. So now we have to look at this as a graph. When you graph something, you know that the way you determine the coordinates of a point is to see how far it goes over on the x-axis and then how far on the y-axis. And so that's very simple to do. We know that this distance, AO, is the square root of 3 over 2, and this distance is 1/2. Now, view this as a graph. Here's the origin right here. So I went in the negative direction, so it's negative square root of 3 over 2, and then I went down the negative direction on the y, so it's negative 1/2. So if you think of that as a graph, and imagine, remember how we find the coordinates of a graph, and I think that you all know that if I wanted to find the coordinates of this point, it would be -2, -2, right? Same thing here, only I don't have integer values. It's the length of this AO, that's square root of 3 over 2, and it's in the negative direction, so negative square root of 3 over 2, and then the length of this to get to that point P, and that's 1/2, but it's in the negative direction, so it's negative 1/2. X coordinate, negative square root of 3 over 2. Y coordinate, negative 1/2. And that's it for that one. The key is to use the information to figure out what kind of triangle this is to get the angle measures. Fortunately for us, it turned out to be one of our special triangles, a 30-60 right triangle. So as long as we know the rules for that, we're in business. See you on the next one.